Hey statisticians! So in this next chapter we're going to be looking at statistical inference and specifically using confidence intervals, which is what we started with the Hershey-Kiss activity today. So the first thing we want to do is define what statistical inference is. And so a formal definition is methods that we use for drawing conclusions about the population from our sample data. And of course, the one thing that we want to remember is that our data has to come from an SRS, or what you're producing could be crap. And we've talked about that. So somebody's going to say, wait, look, you biased your data, or you didn't do this experiment correctly, or all of your conclusions are ridiculous and preposterous. So these values that we've been looking at in the last chapter are what is now formally known as a point estimate. So I'm taking the value from my data and I'm going to estimate information about the population using my sample statistic. So therefore it could be either an X bar or a P hat. Those are the estimators we've looked at so far. And we know that those are going to estimate the population parameter, which is either mu or p. In addition, the ideal point estimator will have no bias and low variability. So looking at some samples, we give IQ tests to 50 seniors, and the mean score is 112. So of course, that would be an X bar, because it came from the sample. And we are assuming, which we won't do this for very long, that we actually know the population standard deviation. Clearly, if I knew that, then I would have had to have known the population mean. So this is really false in that I'm ever going to know this. We're going to see how to fix that in a later section in this chapter, but we'll pretend that we know it for right now. So we're asking if mu is the IQ score for all the seniors, is mu equal to 112? Well, we don't know, and here's why. If we just take one sample, and that's the average that we get, we don't know if we captured the real population value. Just like in the video, we don't know if the one measure of blood pressure that you take, or even the average of, let's say, 10 measures of blood pressure, is your true population or your true blood pressure. So we don't know. We're hoping that it's close, and we're going to build an interval to get close, but from one sample we definitely do not know. However, the standard deviation for the sampling distribution, remember that's sigma of X bar, that I actually can calculate because they gave me the population standard deviation and I know the sample size. And remember, this is if I don't oversample. So my standard deviation for the sampling distribution is going to be 15 over the square root of 50. And then what should the sampling distribution look like? Well, since my sample size is greater than or equal to 30, then it should, by CLT, be normal. And of course, we're thinking that the mean of this sample is equal to the mean of the population, again by central limit theorem, and the standard deviation, of course, we just calculated.